Morning. Well, it's the beginning of winter here in Tasmania. Now you can see I got ice all over my solar panels, and in here I've got this door. It's pretty damn cold actually. I've got my fire lit to start the work for the day, and well, there's the temperature there. It's just coming up to, it's between 3 and 4 degrees C. So it's pretty cold. I mean, it's not as cold in here as what it is outside. A lot of people ask me how I stop my laser from freezing. There's a 100-watt bulb in there, and that burns 24/7 in this weather, and it just keeps, you know, the temperature quite a bit above freezing inside the laser, so it doesn't damage the tube. So that answers that question. So let's get it warmed up in here to start the work for the day. When you tighten something up like this, a ball screw, always turn it with your fingers after you've tightened up all the securing bolts. And if you can't turn the ball screw freely, you know, you've got something out of line. You know, something's pulled out of line, and that's a no-no with a ball screw. Other than if you purposely load up the bearings, like I did on the Z axis, to actually purposely give it a bit of drag to stop it just going down on its own. But this is beautiful, absolutely beautiful, lovely. Okay, so this axis now mechanically is complete, all bar putting the stepper motors on. So I think what I'm going to do now is I start working on the y-axis both sides and getting the screws on and fabricating up a connection similar to this on the y-axis. Well, it's come up a couple of degrees in here now. I think it's 5. I can tell you now, this aluminium is freezing cold, but it'll get better as the day goes on. So I ended up yesterday cutting a piece of, this is 6mm by what is it? 6mm by 60 aluminium angle. So what I wanted is a good solid contact to this Y-axis bearing block. So to make a solid contact to this, what I've done is I've got another piece of that aluminium angle, and I'm going to reverse it around that way, like that. But I do have about a 5mm gap there. Now if I took it all the way up to here, I'm barely going to get the holes in the bottom here. I would have liked to have this up flush with the top there. That really, I don't think really matters. So I may put a shim in between here to space this out a little bit. Little shim plate, and sort of elongate the holes here to give me a little bit of adjustment there. We'll see how we go. So that's the next job. What I will do is I want to drill these holes here first and mount this, preliminary mount this on here to see, well, what we can do, because I've got some 1mm, 2mm and 3mm aluminium plate, which you know, I could cut a small shim plate and put under there, just to make this cosmetically look nice to me anyway. I like things to look nice, you know, not just be functional, but, you know, look pleasant. Okay, so everything is sort of finger tight. Just wiggle it around a little bit, make sure everything is, so you can see the importance now of wiggle room, I suppose. This is just tighten these up, I think. Firm first. The idea is to not have any load on this screw nut here, as in, you know, so you don't want to flex it out of line, as it were. So just squeeze those up, then tighten this up. I've already tightened these. Got my spanner stuck there. One. This is the big test. Oh, beautiful. very important thing, probably I haven't mentioned, and that is underneath here, just make sure when you put your grease nipple in that you put it in an angle that you can get your grease gun on it and grease that bearing up. Okay, don't think I mentioned that, but there you go. You know, I probably could have taken this end off here, and you know, I probably might do that to make it look nice and even and tidy. I'll just take this off, but there you go, a nice solid Y-axis connection. I haven't done the other side yet. The reason being is, you know, I was working out, you know, how I was going to do this, because I like something cosmetically looking nice, and I like it to go with the theme of everything, and it needs to be ultimately functional and long lasting, which I think you'll agree with me that this whole setup is. You know, it's not going to wear out in a hurry. It's very robust, and there you go. So yeah, I think it'll look tidy if I take that off, so that's what I will do. There we are. I'll just give you a little bit of a fly around. So there you go, there's the Y-axis. There, all connected up now. Like I say, I've only done this one side because if I make a mistake on anything here and I'm making parts for two sides, well, that means I have to make it all again. So if I stuff up on a part that doesn't quite work out as I plan, I only have to remake one part. And there's the X-axis, good solid connection there. Look, there's no need to have a 12mm plate, you know, on here like this, but it just so happened that where I had this connected to here, to the Z-axis, it was exactly 12mm from the top of this bearing block here, or connection block, to the underside of here. I thought, well, I've got 12mm plate, put it on there, and I've left this larger just in case I want to connect something onto here, because I'm not sure whether, you know, there's going to be a cable in chain link here, and that's one of the reasons I had these put in here actually, so I could connect flat piece of aluminium along the back here to run the cable chain in. You know, that's one of the things I'm having on the back here. And, you know, I'm not sure whether I'm going to connect it on here or whether I'm going to connect it on here, because I may have a small chain cable link over here to feed the spindle. I may just use flexible conduit, I don't know. But this is what these are extra long for on here, so you know, I can connect whatever I want to connect onto here, and I've also left these long. But then at the end of the process, you know, all I got to do is come along with an angle grinder and a slitting saw and just knock these off and file them, and that'll be fine. So there's a bit of a look. And of course this side hadn't been done yet, which I will do this afternoon. Well, I hope you liked the video today. This is now episode 8, I think, of building the mechanism and mounting the Y-axis screw and making the connection to the y-axis bearing blocks, and again everything is turning out to be pretty hunky-dory, and I'm liking what I'm seeing. It's turning out exactly as I have planned it. I mean, months of planning have gone into this, and it's paying off. I've taken all the, I suppose, good design theories that I have learnt over the past 10 or 15 years that I've been involved with these particular machines, and I've had a few, and nearly every machine that I've purchased from China have had inherent sort of bad design features, because they're not really designed by engineers. They're designed by people who think they know. But well, there you go. You're far better off, especially these days, in building one yourself. I'm still managing. It's just creeping over the $3,000 mark, but it won't be too much over. You can always sort of, before you start a project, you can sort of price things up, and you sort of, when you then get yourself a budget of $3,000 or whatever, there's always unforeseen costs. From the time that you did your estimate, the time that you were ready to buy, there could have been a price increase, the postage has gone up, or postage is no longer free, and a couple of $100 can be put on easily. But we're shooting for around about $3,000 mark. But I'll give a total tally up at the very end. So, if you've liked this video, please like and subscribe, and don't forget all the plans. Some of the plans are on Patron at the moment. For the chassis, they're already on Patron, and the parts list, what I paid for them, and the vendors who I bought them off. So if you would like to become a patron and support this channel, let's face it, it's the patrons behind this channel that allow me to do things like this and bring them to you. So if you're interested in becoming a patron, the information is below this video in the video description area. Also in that area, there's a 20% discount code off Fusion 360 if you want it for a business. There's also a link to a free copy for hobbyists only, but there's enough on there in the free version for you to get started and get to know how to use it, and indeed you use it for your own purposes. And also there's a 5% discount code there for all of the Carveco products. A lot of people are asking me, oh, who's Carveco? It's ArtCAM. ArtCAM, Carveco, same thing, just a modern name for it. Okay? So there's those there for you as well. So until the next video, and I hope you come along and join me. The next video will be making all the bracketry for the stepper motors, and we'll be mounting the stepper motors on here. We've got some turning jobs to do, and I might actually set the I might set the little CNC lathe up a job, because I've got to bore these out, all of them. Okay, so thank you for joining me, and it's bye for now.